process in which a protein called luciferin is oxidized, giving rise to oxyluciferin molecules in excited state. This reaction needs the help of a substance called adenosine triphosphate (ATP), capable of generating the necessary energy to perform this reaction. This reaction is catalyzed by an enzyme called luciferase that makes the reaction faster.
In this project, you will see how to turn your ordinary garden potatoes into a fluorescent magical compound.
In 1845, John Herschel presented his observations on the bioluminescence of quinine for the first time before the Royal Society only. It was the first time that an investigation was presented on this phenomenon, although it could not explain what caused bioluminescence. The research on quinine eventually led to the development of a spectrophotometer in 1950.
Before beginning the experiment, we will explain a method that is important for this project. Spectrophlorimetry is an optical method using analytical measurements. It arose with the first observation of Sir John Frederick William Herschel of a quinine solution seen in sunlight. With quinine, it was possible to develop the first spectrophlorimeter in 1950. It has various applications such as the study of physical processes of molecules, relationships of the structure and function of biomolecule interactions. Disadvantages of this method are its high level of sensitivity and wide range that can be covered when working with it.
The materials that we will use from the experiment are potatoes, tonic water, a bowl, knife, and table, and UV lamp.
Get started by grabbing potatoes and wash the outsides, so they are all nice and clean. Once the pieces are ready, place the pieces in a bowl and add hot water until the pieces are covered and let it rest for 10 minutes.
Next, separate the water from the pieces in another container. After 10 minutes, the formation of the white layer at the bottom of the container is observed. Separate the remaining water from the white layer.
Clean white layer with water. Empty it in a container with lid and shake. Let it set down for 10 minutes so that the faces separate again. Empty water, leaving a pure white layer, and handle the content carefully.
Make mixture of tonic water with white layer in a container.
The quinine is used as a flavor enhancer in tonic water, giving it its characteristic bitter taste. Quinine is an alkaloid that is extracted from the bark of a tree called cinchona. The tree is the most commonly found in South America, Central America, and the island of the Caribbean. Quinine was originally developed as a medicine to fight malaria.
White layer is formed. Why does this happen? Starch is extracted from the potatoes.
The starch grain of a potato is larger than rice grain or even corn grain. Since starch is not soluble in water because its structure is highly organized, the layer can be separated from the water we add.
Potato starch contains mostly amylose and also amylopectin. Amylose's structure is simple and is capable of forming hydrogen bonds with water. This phenomenon is called starch gelatinization.
Under a black light, the quinine in tonic water makes the water fluoresce a brilliant blue. The fluorescence consists in the absorption of electromagnetic radiation by certain molecules, which pass to an excited state to subsequently emit electromagnetic radiation. The intensity of that emitted radiation is proportional to the concentration of fluorogen in the sample. The zone of the most used spectrum is the region of the near ultraviolet, reason why the fluorescent emission will take place next to the visible one or in him. Quinine contains phosphorus. These substances glow when they are hit with particular wavelengths in the EM spectrum, including UV light. Phosphorus absorbs UV light and then emits it in their own color. Thus, the black light's UV light radiation is absorbed by the phosphorus in the quinine, and then emitted again in the form of glowing blue light.
Fluorescence principle is fundamental to analyze the quality of food based on certain components. In dairy products, for example, this technique is used for fluorescent molecules such as aromatic amino acids, nucleic acids, tryptophan, riboflavin, vitamin A. Likewise, it is useful as a method of quality control for meat and fish products, based on the fluorescent properties of bone, cartilage, connective tissues. During freezing and storage of the fish, the muscle may suffer from protein denaturation and lipid oxidation. They can be measured with this technique.